All right, we're on problem 59. 59 on page 282. If a real estate agent received a commission of 6% of the selling price of a certain house, what was the selling price of the house? So the price of the house. Price of house. And they just told us that the real estate agent received 6%, but that alone doesn't tell us much. So statement number 1, they tell us the selling price minus the real estate agent's commission was $84,600. So let's see if we can write that algebraically. The selling price, let's say P for price, minus the real estate agent's commission. Well, they told us at the beginning the real estate received a 6% of the selling price. So that's 0.06, 6% of the price. So they're telling us that that is equal to $84,600. Well, we're done. That's a linear equation with one unknown. This is algebra 1. You can solve for this. Let's see. This is, you could say this is, I mean, if you had to, if you wanted this 0.94 P is equal to 84,600, and then you'd have P is equal to 84,600 divided by 0.94, whatever that is. You get your calculator, but we don't care. We just have to know that we could solve it. Well, since we got so close, let's just solve it. 84,600 divided by 0.9. This is a bad habit when you're taking the GMAT. You want to just know that you could solve it. So the selling price of the house is $90,000. We didn't have to solve that. That would be a waste of time on the real GMAT. But I just wanted to show you how easy it was to solve. Statement number 2. Statement number 2. Let's see if this is independently useful. The selling price was 250% of the original purchase price of $36,000. Well, this is okay. So the price, we chose P as the selling price, right? The selling price minus, right? Everything we talked about before was the selling price, and now they introduced this thing called the purchase price. So the price selling is equal to, and that's what we want to figure out, is equal to 250%. So that's 2.5 times the purchase price of $36,000. So times $36,000. 36,000. Actually, we didn't have to write this. So the price is 2.5 times 36,000, which is, I'm guessing, let's see, 72. Yep, it's $90,000 again. We didn't have to do that. But once again, this is just a this is actually not even algebra. You just have to multiply 2.5 times 36,000, you get the answer. So each of these independently are enough to solve this problem. So that's D. Next problem. 60. This yellow is a little bit over the top. Let me do a more muted color. So they write, if the square root of x over y is equal to, what does that say? D? Right. Is that what they wrote? Is equal to D? Oh, no, that's equal to n, I think. Right. Is equal to n. What is the value of x? So statement number 1, they tell us that yn is equal to 10. Well, this is pretty useful because this first equation they gave us, we've just multiplied both sides by y. We get square root of x is equal to yn, right? Y times both sides gets us this. And if yn is equal to 10, then we know that the square root of x is equal to 10. So x is equal to 100. So statement 1 alone is enough. Now what does statement 2 do for us? They tell us y is equal to 40 and n is equal to 1/4. So once again, they substituted everything else, so we just have to solve for x. So both of these individually are enough, so the answer is D. But we could, solve for it just for fun. We get square root of x over 40 is equal to 1/4. And then you get, essentially solving this, you get square root of x is equal to 10, and you get the same thing. X is equal to 100. And you are all done. Right? And you might say, oh, but isn't there a plus or minus? No, because we're taking the square root of something is equal to 10. We're not saying the square root of 100 is what? If you said, what is the square root of 100? You'd say, oh, it's plus or minus 10. But if we said the square root of something is 10, that something has to be 100. Anyway, next problem. Don't want to dilly-dally. 61. I want to imbue you with a sense of urgency for the GMAT. How many integers are there between but not including r and s? Fair enough. So essentially we have to figure out what r and s are, or how far apart they are. So statement number 1, so integers between R and S, but not including. Remember, not including. So statement number 1 tells us that R minus S is equal to 10. Now, this is an interesting a question, because if we knew that R and S were integers, then this could be, we could just pick R minus S is maybe R is equal to 11 and S is equal to 1. And then if you actually just want me to write it out, you could say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many integers are between the two and not equaling the two? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? But that's if we assume that R and S are integers. And this would work for any two sets of integers that are 10 apart. But what happens if we do it a little bit differently? What happens if we say that this is 1.1, 2.1, 3.1? Oh, no, sorry. What if it's between 1.1 and 11.1? So if it's 1.1 is R. Oh, let me write it this way. What if R was 11.1 and S was equal to 1.1? Then what are the integers between them but not equal? So you start at 1.1, you would have 2, 3, 4, 5, 6, 7, 8, 9, 10. And now 11 would be included because 11 would still be less than R. 10, 11. So now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So statement number 1 is actually not enough because they didn't tell us that R and S are integers. If R and S were integers, then the answer would be 9 in this case. But if R and S are not integers, then the answer could be 10. So statement number 1 alone is not enough. The answer could be 9 or 10. Okay, what does statement number 2 do for us? Let me do a different color. Statement number 2 is an interesting problem. There are 9 integers between, but not including R plus 1, and S plus 1. Okay, so this is interesting. So they're telling us that there are 9 integers between R plus 1 and S plus 1. So I mean, actually just looking at it inspection, you could say, oh, well then there are 9 integers between R and S. And they say, but not including. So this is enough. This alone is sufficient, and you don't need statement number 1. Statement number 1 actually doesn't get you anywhere. So let me prove to you that if there are 9 integers between R plus 1 and S plus 1, well, think of it this way. If there are 9 integers between R plus 1 and S plus 1, if you subtract 1, so S is one of the ones that are between. Now I want to make sure I do this right. So if let me think of a good way for me to prove it to you. Well, I'll just do it with an example. So let's say that the example is, well, the only example, let's say it's 11 and 1, right? This isn't a proof, but I just want to give you the intuition, right? So if R is 11 and S is 1, so then you would have 12. Well, I don't want to do it that way. The easiest way to think about it is, it doesn't matter how much you are adding. If you add the same amount to both the bottom of the range and the top of the range, it should not change the total number of integers that are between them. So if you were to say, so there would also be 9 integers between R minus 1 and S minus 1. You're just shifting the range along the number line, but you're not going to actually change the number of integers in between them. So if there are 9 integers between R plus 1 and S plus 1, there's going to be 9 integers between R and S. So 2 is all you need. Hopefully that's a satisfactory explanation. I didn't want to go into something rigorous when we're trying to imbue you with a sense of urgency. Let's see if I have time for the next problem. Okay, 62. 62. What is the number of members of Club X who are at least 35 years of age? So age, so number whose age is at least 35. So it's greater than or equal to 35. The number whose age is true. Okay, they tell us, statement number 1. Exactly 3/4 of the members of Club X are under 35 years of age. So 3/4 are less than 35. That is fair enough, but that doesn't tell us the number that are at least 35. This tells us the percentage. This tells us that 1/4 above, or we could say 1/4 greater than or equal to 35. 1/4 of total members greater than or equal to 35. But it doesn't, so it tells us the proportion, but it doesn't tell us the total amount. And I just got the 1/4 from, 3/4 are less than 35, 1/4 are going to be greater than or equal to 35 years of age. So 1 by itself doesn't help us. Let's see what 2 does for us. The 64 women, am I reading the same problem? Okay, yeah. The 64 women in Club X constitute 40% of the club's membership. Okay, so 64 is equal to 40% of the total membership. Now we're set, right? Because we can use this equation to figure out the total membership. Call it T for total. T is going to be equal to 64 divided by 0.4. Right? They just told us that statement essentially that 64 is 40% of the total. They said it's the women and all of that, but they could have just told us that 64 is 40% of the total. So then you can solve for the total, and then you substitute that here, and you say 1/4 of the total are 35 years or older, and you get what we were trying to solve for. And so the answer is 1/4 times 64 over 0.4. And whatever that is, you can put it in your calculator. But all we have to care is that when you use both of these equations combined, you are able to solve for the number that are greater than or equal to 35 years old. And each statement alone isn't sufficient. So you need both statements. And that is C. Both statements together are sufficient. See you in the next video.